Welcome. Today we are doing systems of linear equations. Okay, so sometimes we have to solve one equation where there's one variable, but sometimes we're also going to need to solve multiple equations with multiple variables kind of simultaneously, right? So we're trying to find basically where two lines intersect. Okay, so let's say we start with 2x plus 3y equals 6. And then the other equation that we're going to have is 3x minus 2y is equal to 8. So we're going to try to solve these two simultaneously. Now, one way that you've probably learned is substitution. So that's where we solve for one variable and then we solve for the other variable. So first I'm going to isolate y in terms of x. So I subtract 2x from both sides in the first equation and then I divide by 3. So I end up getting negative 2/3 x plus 2. Okay, so now I've solved for y in terms of x. So what I can do with that information is I can plug that whole thing in, which is equal to y, in for y, right? So I'm subbing that entire phrase into where y is. So I'll have 3x minus 2 times negative 2/3 x plus 2, and that's going to be equal to 8. Then I distribute the 2, so I get plus 4/3 x, and then minus 4, right? The negative has to distribute. I'm going to combine the 4/3 and the 3x, so 3 is 9/3, so then that becomes 13/3 x when I add 9 and 4. And that's going to be equal to 12 once I add 4 to both sides. Then I'm going to multiply by the reciprocal to cancel that 13 over 3. I end up getting x is equal to 36 over 13. Okay, so then all I have to do from there is plug in what I got for x into that first equation where I solve for y. So once I plug in x there and I add 2, I'm going to cancel the 3 and the 36, and I'm going to change 2 to 26 over 13. Then I'm adding, similar terms with the same denominator, and I end up getting y is equal to 2 over 13. So if I've solved these two simultaneously and gotten answers for x and y. Now, we're going to look at this with a different method of solving, where we're actually going to add the two equations together. So I'm going to look at y, and I'm actually going to try to get them to have the same coefficient but opposite sign. So I'm going to multiply the entire first equation by 2 and the entire second equation by 3. I end up getting 4x plus 6y is equal to 12, and then 9x minus 6y is equal to 24. Okay, so if I add these together, you'll notice first I get 36 on the other side, but then if I add the 6y and the negative 6y, that cancels to 0y. So this gives me 13x, and then I can easily solve for x because that's the only variable, and you see that it's the same that I got before. So then once again, once I have x, I can find y, just in the same manner. So I'm actually always going to use this method rather than substitution because I find it much easier. So let's say we have another problem. We have these two equations which we want to solve, and you can use substitution if you want, but I really don't like using it. So instead of using substitution, I'm going to multiply this bottom equation by 3 so I can get negative 3y on the top and 3y on the bottom. Okay, so you notice that I'm just writing the first equation again on the bottom, and I'm adding these two together. So I get 11x, and then those cancel out to 0y. That's good, that's your goal, right? And then I get 22 on the other side. I just divide by 11, and I get x equals 2. And then I'm going to take that answer for x and I'm going to plug it into one of the above equations. It doesn't actually matter which one. I'm going to choose the bottom one. So I get 3 times 2 plus y equals 5. And then if I solve for y, I end up getting y is equal to negative 1. Now I can write this as an ordered pair, which I'll show in a moment. But let's go ahead and do one more example before we get to that. So let's say I have 2x plus y is equal to 2 minus x. And x plus 2y is equal to 2 plus y. Okay, so first thing we need to do is I need to get all the x's and y's on one side and all the numbers on the other side. So I'm going to add x to both sides, subtract y from both sides in the other equation, and I end up with 3x plus y is equal to 2, and then x plus y is equal to 2. Again, I'm going to use the same method. Now this time I realize all I have to do is make the bottom y negative, and then I can add these together. Now you don't always need to make the y's cancel out to 0. You can also make the x's cancel out to 0. It's just your preference. So I end up with x equals 0. You can pause the video and go back if you need to work through that more slowly. And then all I do is plug it into the top equation. So 3 times 0 plus y equals 2. I end up with y equals 2. I'm going to write this as an ordered pair with x comma y, so that's 0 comma 2. I'm going to do it again with this one. So then I get 2 comma negative 1, and then with the first one that we did, it would be 36 over 13 comma 2 over 13. So that's how you write it as an ordered pair. Okay, so we're going to move on. We're going to do another example. Let's say I have 6x equals 4y plus 5, and then I have 6y equals 9x minus 5. Okay, so I'm going to rearrange these so that my y's are on one, my x's and y's are all on the same side. So I'm going to subtract 4y from the top one, and then I'm going to subtract 9x from the bottom one, right? And I'm just going to put the x's and y's together. So I see that the top equation and the bottom equation, I want to get the same coefficient for y. So what I do is I multiply the top one by 3 so I can get negative 12, and the bottom one by 2 so I can get negative 12 or positive 12 in front of y. So then I see that if I multiply everything out, I end up getting this 18x, negative 18x. So I get 0 for x, but I also cancel out my y's. And then I get 5 on the other side. Well, so then I have something that says, well, 0 equals 5. Well, that's not true. Therefore, there's no solution for this because I've come up with an equals that is actually not true. That means that these two lines never actually touch each other, okay? So I'll make another video where I can show you how these graphically work out. They're probably parallel lines. One last example that we'll do is where we have 6 over u plus 5 over v equals 1, and 3 over u minus 10 over v equals 3. So I'm going to sub x equals 1 over u and y equals 1 over v, so that my equations just become 6x plus 5 equals 1, and 3x minus 10y equals 3. So I'm going to multiply the top one by 2 so that I get 10y to cancel out with that negative 10y. And then all I'm going to do is add the two equations to get 15x is equal to 5, and then x would be equal to 1 over, well, it's 5 over 15, which is 1 over 3. Okay, but remember, x was equal to 1 over u, right? And I have 1 over 3. So you could think of like flipping x, or you could just think of the bottom being the u value, right? So u equals 3. Okay, so now I'm about to make a mistake here, but I get 3 times 1/3, right, because I'm plugging x back in, and that should equal 1. 3 times 1/3 is 1, not 0, which is what I did there. So you'd actually get a different value for v here, but hopefully you guys can rework that and fix my mistake. Have a great day, and enjoy your homework.